Okay, let's take a look at this long question. It says, production supervisor of Alexandra's office products find that it takes 3 hours to manufacture a particular office chair and 6 hours to manufacture a desk. Okay, a total of 1,200 hours. Okay, a total of 1,200 hours is available, and the linear equation that models that is this. Okay, and we want X to represent the number of chairs, Y to represent the number of desks, and we want to know, we want to finish this ordered pair and say what this actually represents. Okay, so that's the question. So let's take a look. Okay, here's the deal. They're telling me Y is 0. So if Y is 0, I'm going to go 3X plus 6 times 0 equals 1,200, which is 3X equals 1,200, divide by 3, and we're going to get X equals 400. So okay, now here's the deal. Here's what this represents. This says that, remember, X is the chairs. So this is the chairs, and this is the desks. So this is what it says. Remember, we have this constraint, 1,200 hours. In 1,200 hours, we can construct, make, manufacture, whatever you want to say, 400 chairs and 0 desks. That's what it says. We can construct 400 chairs and 0 desks. Which makes sense, because it takes 3 hours to do a chair. 3 times 400 is 1,200. So that's what that says. And that's it. So let's take a closer look at why we cared about this and why we wanted to do this. So let's look at the next group of questions. All right, let's take a look at this. 0, 8 is the first thing I want to graph. This is 0, 8. 0 on X, 8 on Y. 0, 8. Okay? I'm going to label that number 1, 0, 8. Number 2 is 0, negative 3. So 0, negative 3. Negative 1, negative 2, there's your negative 3. 0, negative 3. There's your number 2. 0, negative 3. Number 3, 0, 4. 0 on X, 4 on Y. Here's your 4 on Y. There's your number 3. 0 on X, 4 on Y. Why do I keep doing the same points? I want you to notice something. When X is 0, as in those first 3 examples, when X is 0 and Y is some number, where will your point always be? Your point will always be on the Y-axis. Why is that true? Because if your X is 0, that means you can't move left or right. So you're only going to move up or down. So when X is 0, your point will be on the Y-axis. Okay? Let's talk about now 3 other examples where your Y is 0. Let's talk about 2, 0. 2, 0. 2 on X, 0 on Y. Don't go up or down. 0 on Y. This is the 4th point. And 5th, negative 5, 0. Negative 1, negative 2, negative 3, negative 4, negative 5, 0. Right here. Right? That's point 5. Okay? And finally, point 6, negative 1, 0. Negative 1, 0. Here your Y's were 0. When your Y's were 0, where was the point? Well, if your Y's were the ones that were 0, that means your point is on the X-axis, because if your Y's are 0, it means that you can't move up or down. You can only move left or right. So when Y equals 0, your point will be on the X-axis, which brings us to a definition. Okay, the definition of the X and Y intercept. The Y-intercepts are the points where the graph crosses the Y-axis. So right now, this is a Y-intercept because it crosses the Y-axis. Okay, and I could either say the Y-intercept is 0, 8 or just 8. Because if we say the Y-intercept is 8, we know by definition X must be 0. Okay, because that's the point 0, 8. That's a Y-intercept, that's a Y-intercept, that's a Y-intercept, because where it crosses the Y-axis. These are X-intercepts, the points where the graph crosses the X-axis. Okay? We could either say this guy right here is negative 1, 0, or an X-intercept of negative 1. You don't have to give the entire point if you don't want to, because we know if we say the X-intercept, Y must be 0. So let's go get some X and Y intercepts, both geometrically and algebraically. So we're going to look at some graphs first. When we say we're going to find them geometrically, it means we're just going to look at the graph. So notice this point right here. This is the point X is 2. That's a bad marker. This is the point X is 2, Y is 0. And that is where the graph is the green thing. This black thing is just the location, just the coordinate plane. Okay, 2, 0 is the point, and that's where the graph, the green graph Green grass? No. Green graph, that's where it crosses the x-axis, so it is called the x-intercept. So we can say the x-intercept is 2, 0, or the x-intercept is 2. Okay? Now for the y-intercept. The y-intercept is 6 because that's where the graph crosses the y-axis. So we can say that point is either 0, 6, or the y-intercept is just 6. Because remember we said the x-intercept will be found whenever y is 0. The y-intercept will be found whenever x is 0. Okay? So the y-intercept is 6 or 0, 6. The x-intercept is 2 or 2, 0. And that's how you find the intercept. You just look at the graphs. So in the next 3 graphs in your workbook, would you just pick out all the x and y intercepts? All right, let's take a look at these 3 graphs. This is a circle. Ha, I'm a genius. This is something called a parabola, and this is a V. Another genius. This actually comes from an absolute value function. Okay, you'll learn more about that in intermediate and college algebra. Yes, I stutter, but I stutter on purpose. Okay, so let's look at x and y intercepts. Well, this graph, this parabola, okay, does not hit the x-axis at all, so it has no x-intercepts. So there are no x-intercepts. However, it does have one y-intercept right there. Okay, the y-intercept is right here. So the y-intercept is 3 or 0, 3. But we know it was 0 for x because that's the definition of the y-intercept. It occurs when x is 0. So that's it for that problem. This problem is a lot more fun. This problem, well, let me write here x-intercepts none. Okay, this problem has 2 x-intercepts. Oh my gosh. It has 2 x-intercepts. It has an x-intercept right here at -5. Has an x-intercept right here at 5. So one x-intercept is -5, 0. And another one is, shouldn't say or, another one is 5, 0. And of course, you can just say -5 and 5 if you'd like. The y-intercept is where it crosses the y-axis, and this is the y-axis, and crosses it again at -5. So you can just say -5, or you could say 0, -5. Okay? So that's it, x and y intercepts. This is easy. This is a circle if you can see it, but it's in your workbook. The circle has x-intercepts and y-intercept, this particular circle. Okay? The x-intercept, it has 2. It has the x-intercept 2, 0. Notice x is 2, but y is 0. Okay, and it has the x-intercept -2, 0. The y-intercept is just reverse. The y-intercept is 0, -2, and 0, 2. So it has 2x and 2 y-intercepts. That's all you do when you have to find intercepts graphically. Okay? Now, I want to talk about this. Will a line always have an intercept? That's kind of interesting. Will a line always have an intercept? Well, it's a line, right? A line means that it has to go on indefinitely both ways without end. Now, if I draw a line like, I'm going to use this, if I draw a line like that, that obviously has 2 intercepts, an x and a y. What if we draw a line like this? That line will have an x-intercept, but not a y-intercept. Okay? If we draw a line like this, that line will have a y-intercept, but not an x-intercept. So will a line always have an intercept? Yes, a line, because remember, it keeps, even if I drew, you might go, well, look, I'll draw it like this. Well, except that there's arrows. So the arrows mean it keeps going. So a line will always have an intercept, but it may not have both intercepts. It may not have an x and a y-intercept. Okay? Can the same point ever be the both x and y-intercept of a graph? Think about it. The same point. That means x has to be 0, but y has to be 0, right? So, of course, that means it's got to go through the center. So that means if my graph, no matter what it is, goes through the center, goes through the origin, meant origin, that means center, goes through the origin, 0, 0. If your graph goes through 0, 0, that point is both the x-intercept and the y-intercept because it crosses the x-axis as well as the y-axis. So yes, it can if it goes through the origin. Okay, so let's take a look at finding intercepts algebraically. All right, and we'll do that next. All right, so here's the deal. To find the x and y intercept algebraically, it says this in your notes, that you have to set y equals 0 to get your x-intercept and x equals 0 to get your y-intercept. We already learned before, when I did that really bad line, that if to get a point, all you need is one part of the point. Then you plug it in, you get the other point. So watch what I mean. Let's get the x-intercept. To get the x-intercept, y has to be 0. So here we go. Okay. Y has to be 0. That would be nice to make y 0. Here we go. 0 minus 2x equals 6 because I'm making y 0. So I get negative 2x equals 6. Divide by negative 2. Divide by negative 2. X equals negative 3. So I now have the point negative 3 comma 0. So when I want the x-intercept, I have an x here. There's the x, y is 0. So the x-intercept is negative 3. Now I have to do the same thing for the y-intercept, okay? I have to make x 0. And I think I thought I could fit a lot more on this board, so I'm going to take care of that. Don't worry about it. Let's do the y-intercept. That occurs when x equals 0. So our equation says y minus 2x equals 6. I'm going to make x 0. This just says y equals 6. So there's your point 0, 6. Because remember that you made x equals 0. X equals 0. So there's your point 0, 6. 0, 6. If it's easier for you to make a little graph, a chart like this, so that you remember to use those zeros in your points, you can do that. Because this will give me the y-intercept, x is 0. This will give me the x-intercept, y is 0. That's absolutely up to you. Okay? So let me do number 2. Number 2 is a little harder because it has lots and lots and lots of fractions. So number 2 says 3/4 x plus 1/6 y equals 2. Okay? I don't like that because it's not that I don't like fractions, but it's easier if I don't have fractions. So I'm going to clear these denominators, which means I'm going to multiply by the LCD, and the LCD is 12. Okay? So here we go. Oh, I'm squishing. Okay, here we go. No squishing. 4 goes into 4 once. 4 goes into 12 3 times. 6 goes into 6 once. 6 goes into 12 twice. We get 3 times 3, or 9x, plus 2y equals 24. Okay? You ready? Here we go. X-intercept. Y has to be 0. That's how we get the x-intercept. So 9x plus 2 times 0 equals 24. So remember, y is 0. So right now we're making y 0. Don't forget that. Okay, we get 9x. Oh, it's not going to be pretty. Definitely not going to be pretty. Divide by 9. Divide by 9. X equals 24 ninths. But if I wanted to graph that, that's not helpful for me. So I'm going to go 2. 9 goes into 24 18 times with 6 left over. Oh, of course, I have to keep reducing. 2 and 2/3. So it's 2 and 2/3, comma 0. That is my x-intercept. Now I have to make my y-intercept. I'll do that here. Oh, look, I wrote y in before. That's okay. You know I meant intercept. And x is going to be 0. So I'm going to have the point 0, comma something. 9x plus 2y equals 24. Okay? And now y is 0. Sorry, x is 0. I'm finding y-intercept. I'm sorry. I'm finding the y-intercept. X is 0. 9 times 0 plus 2y equals 24. 2y is 24. Divide by 2. So y is 12. So we have the point 0, 12. So your y-intercept is 0, 12. Your x-intercept is 2 and 2/3, comma 0. Okay? And that's how you find the x and y-intercepts. We got 3 more to do, and then we're going to give you something to do. All right? Here we go. We want to find the x-intercept. That means y has to be 0. Here we go. So 0 equals negative 2x. divide by negative 2, divide by negative 2. So x is 0. That means we have the point 0, 0. So guess what? That's not only the x-intercept, that is the y-intercept as well. Watch. If I want to find the y-intercept, we have to make x equal 0. Well, if we make x equals 0, then we got y equals negative 2 times 0, which is 0. Why? Because we just talked about that. If you have the origin, then that is the x and the y-intercept. So this graph goes directly through the origin, 0, 0. Okay? So there's one intercept for that question. X equals 4. Now this is really interesting. Watch. The x-intercept, y must be 0. Well, I can't even plug in for y. I don't have a y. But that's okay, because we said that if it didn't have a variable, then that variable could be anything. X must be 4. Y has to be 0 then, if you want the x-intercept. So the intercept of that is 4, 0. Okay? Well, now let's try to get a y-intercept. That means x is 0. Well, here's the problem with that. X can't be 0, because x has to be 4. X can't equal 0. No y-intercept. Just to show you, I'm going to show you what that graph looks like. I'm going to take it off the board in a second, but I'm going to show you what it looks like. This graph goes through 4, 0, right? 1, 2, 3, 4. I need one more point, at least one more point to graph. I can't make a line through there. I don't know how it goes. Okay? All right, so here's the deal. I have to get at least one more point. We know x is 4, so any other point, 4 anything. 4, 2 would work. 4, 2. It's not an intercept, but it would work. And notice, that's this vertical line, so it does not have a y-intercept. That's why it came out that way. Okay? All right, let's look at y equals 0. Y equals 0. If we want an x-intercept, y must be 0. Well, y is 0. That's the definition of this line. X can be anything. That means there's an infinite number of intercepts. Every number, comma 0 is a y-intercept. Sorry, x-intercept here, and I'll talk about y in a second. Every number is an intercept. There's infinitely many intercepts. We'll talk about y. How about y-intercept? Y-intercept, x must be 0. X can be 0. Because it says y has to be 0, we make it 0, but x can be 0 also. So that's the y-intercept. It's also the x-intercept, but it's not the only x-intercept. Watch this line. I gave you this on purpose. I know, what a thrill, huh? Here's your 0, 0. And we said any number 0. So here's 4, 0. This is your... This x-axis is y equals 0. The x-axis is another name for y equals 0. So there's infinitely many x-intercepts because it hits that point. That graph hits every single point there. So there's infinitely many x-intercepts, and there's one y-intercept. The only y-intercept is 0, 0. So that's how you do that algebraically. All right, so now you know how to solve these algebraically. If you want the x-intercept, you make y0. If you want the y-intercept, you make x0. Now let's see why well, before we see why it's useful, which we already see, we can get some points, let's have you try some. Okay, let's see how you did. Here we go. We're going to find the x and y-intercepts. So the first thing I'm going to do is going to find the x-intercept. I'll find the x-intercepts by making y equal to 0. Okay, so here we go. I'm going to do this so we don't forget to do it at the end. So I have 3x, and look, I made this so nice for you. 3x minus 4 times 0 equals 12, which is 3x equals 12, which if I divide by 3, I get x equals 4. So this is 4, 0. So that's my x-intercept. Now I'm going to do my y-intercept. My y-intercept occurs when x equals 0, the opposite one. So I have 3 times 0 minus 4y equals 12. That's negative 4y equals 12. Divide by negative 4, and I get y equals negative 3. So remember, my x was 0, my y is negative 3. So there's my x and my y-intercept. My x, my y-intercept. Okay? Let's try this one. I don't know what you did, but I think I'm going to multiply everything by 4 to clear that fraction. Here we go. Multiply by 4. Multiply by 4. Multiply by 4. Okay? Reduce. We get x plus 4y equals 8. I think this is going to be easy. Okay, here we go. To get the x-intercept, I have to make y equals 0. So I'm going to write this like this. Okay? Y is 0. That tells me x is 8. Look, y is 0. Oh, I did that in my head, didn't I? I'm sorry. I didn't even realize I did that in my head. Let's do that again. All right. I was so excited about it. All right. It's x plus 4 times 0 equals 8. So 4 times 0 is 0, so it's just x equals 8. All right. I was happy that too. The y-intercept, x has to be 0. So if x is 0, we get 0 plus 4y equals 8, or 4y equals 8. Divide by 4. Divide by 4. We get y equals 2. So that's 0, 2. So there's your x, there's your y-intercept. Pretty cool, pretty easy. I did the hard ones, I think. I think I gave you the easy ones. I hope you were listening before, because watch this. Okay, x-intercept, y equals 0. So 5 times 0 equals x. So 0 equals x. So this is 0, 0. If this is the x-intercept, it's also the y-intercept. Just to make sure you understand that there were no other intercepts, because this is going to be a line. Okay, I have to tell you, I wasn't supposed to tell you this till the next section, but I'm going to tell you now that these are linear equations in 2 variables. And linear equations, linear, what's part of the word linear but line? L-I-N-E-A-R. So linear equations will give you lines. So you're never going to need a line that's going to have more than one x and y intercept. Okay, it may have an x and a y, but it won't have 2 x's or 2, because that means it's got to turn. Lines don't turn around. All lines are straight. So I'll prove it to you, but the y-intercept is going to be the same. 5y equals 0. Divide by 5. There's your 0. So we get 0, 0. Okay, so you have one x and y-intercept. It is 0, 0. Okay, y is negative 2. To find the x-intercept, y has to be 0. Y can't be 0, because y has to be negative 2. That's defined as that. So there is no x-intercepts. For the y-intercepts, you have to make x 0. Well, can I do it? Yes. As long as I have y as negative 2, I can do it. So there's my y-intercept. I love the one variable. See, this is one variable. This is 2 variables. One variable, 2 variables. One variable, there's always going to be non-diagonal lines when they're graphed. Very cool. X-intercept, y has to be 0. Well, let's see. Can we make y 0? Yes, we can, as long as x is 0. So we have one x-intercept. But what about the y-intercept? Y-intercept, x must be 0. Well, x is always 0. So x is 0, and then we can have any real number for y. So we have an infinitely many y-intercepts, because x equals 0 is actually the y-axis. X equals 0 is actually the y-axis. So it has infinitely many y-intercepts, because that whole line is the x equals 0, and every point on that line is a y-intercept. Okay, let's see how the intercepts can help us graph. All right, let's take a look at this. We already know how to graph linear equations. We did that in the last lesson, but now we're going to talk about graphing them using the intercepts. Okay, we know that we wanted 3 points last time, so 1 was for insurance. We know 2 points make up a line, but a lot of people get 3 just for insurance to make sure those points are right. Okay, well, for the intercepts, if you have an x-intercept and you have the y-intercept, that's only 2. That means you're going to have to find 1 more. Okay, so here's what we're going to do. To graph using the intercept method, the first thing you're going to do is find the intercepts. So we're going to find the x-intercept. I'm going to make a little chart. It's saying to graph. Whenever it says to graph, I'm going to make a chart. I'm going to find the x-intercept and the y-intercept. This will give me the y-intercept, because x is 0. This will give me the x-intercept, because y is 0. Okay, y-intercept, x is 0, x-intercept, y is 0. And I'm going to just find it here. Here we go. So I'm going to find the y-intercept first, just because I put it up here. It doesn't matter. X equals 0. Y equals 3 times 0 plus 6. That's y equals 6. So I already have a point 0.06. Okay? Now I'm going to find the x-intercept when y is 0. When y is 0, I'm going to get 0 equals 3x plus 6. I'm going to subtract 6. I'm going to get negative 6 equals 3x. I'm going to divide by 3. I'm going to get negative 2 equals x. So that's 0, negative 2 for the x. Sorry about that. So that's negative 2 comma 0. Okay, because we made y 0. Now I need another point if I want 3 points. So I need another number, any number I want. I can pick any number I want. And this is really just for insurance. Let me show you why. I have 0.6 already. Here is 0.6. Okay, I have negative 2, 0. Here is negative 2, 0. I can definitely connect the line, but for insurance, I want to pick another point to make sure those points are right, because if those points are right, my next point will make sure we are collinear, all on the same straight line. So maybe, I don't know, maybe you want to pick negative 1 for x. I have no idea. I will say this, we've talked about this, that if it's solved for y, it's easy to pick an x, so that's what we're going to do. We talked about that in the last lesson. So I'm going to pick negative 1 for x. And then we got y equals 3 times negative 1 plus 6, which is y equals negative 3 plus 6, which is y equals 3. So that gives me the point negative 1, 3. So negative 1, 3. And notice how beautiful. All on the same straight line. Okay, all lines are straight, but all on that same line. So now I'm going to connect them. Okay? I think my straight edge ran away, but it's okay. And there's my line. And of course, we knew from the last lesson it was going to be diagonal because I can see 2 variables. So there's my line. Y equals 3x plus 6. And that's how I can graph using the intercept method. So there's 2 problems left that I'm going to ask you to do doing the intercept method. Now, listen, if you have 1 point for the intercept, just 0, 0, what do you have to do then? Well, then you have to pick 2 more numbers and plug them in. So it's really simple. So try the next 2. Okay, let's take a look at this. We're going to first get the x and y intercepts, and then we're going to have to get another point to have our third insurance point. Okay, so we have 0, 0. Okay, so to find the y-intercept, we're going to make x equals 0. I'm only doing that first because that's what I keep writing here. It doesn't matter. Okay, so 3 times 0 minus y equals 9. I get minus y equals 9. Divide by negative 1. I get y equals negative 9. Oh, that's going to be fun. Okay, when y equals 0 now, we're going to find the x-intercept. Okay, and we get 3x minus 0 equals 9, which is 3x equals 9. Divide by 3. Divide by 3. We get x equals 3. Okay? So that's the point 3, 0. Now we're going to pick another point. It really doesn't matter what point we pick. Let's say we pick x is, I don't know, 1. Okay, so if we pick 1, we get 3x minus y equals 9, right? So we get 3 times 1 minus y equals 9, which is 3 minus y equals 9. So now we're going to subtract 3. Subtract 3. Minus y equals 6. Divide by negative 1. Y equals negative 6. Okay, so I'm glad we did that because 0, negative 9 is actually clear off my thing, but I'll talk about that when we get our graph in there. 3, 0 is right here. Okay, 1, negative 6. 1, negative 6. 1, negative 6 is right here. Okay? And 0 and negative 9 is like down here somewhere. Okay? Anyway, graphing that. And of course, now I don't have my insurance, but it's okay because I know it's right. And we get this line here. Oh, and again, here you go. Make that bigger. All right. I need to be better with a ruler, obviously. Okay, so that's that line. Obviously, we knew it was going to be diagonal because there are two variables there. Okay? And we're going to clear this board and get up the next line. All right, let's take a look at this. We're going to make y 0, and then we'll get our x-intercept. We make y 0. Okay. If y is 0, we get 0 equals negative x. We divide by negative 1, and we get 0 equals x. Well, that means that gives us that point. So I can't make x 0 because I'm going to get that same thing here. I'm going to get 0, 0. So now I need to get 2 more points. It doesn't matter what points I get. Let's say I take x is 2. Let's say I take x is negative 2. It doesn't matter. If x is negative 2, we know y equals negative x, but x is negative 2, so I have to go y equals negative 2. That tells me y is 2. Because all this says is y is the opposite of x. Y is the opposite of x. And these are opposites, and these are opposites. Even if I picked an x, watch. I was going to make it an x. That's smart. Okay, if I make x3, we're going to have y, I'm sorry, yeah, x3, we have y equals, I did do that right. Okay, y equals negative x. I make x3, y equals negative 3, which is just negative 3. I could have picked a y. It doesn't matter what I pick. Pick either one, plug it in. So now I'm going to put this on the same graph just to make it a little easier. And here's what I have. I have 0, 0. Which is right here. I have negative 2, 2, negative 2, 2, and I have 3, negative 3. 3, negative 3. Okay? And that's the way my graph looks, and they are collinear points. Okay? So I'm going to make this fall. It's okay. Don't worry about it. I'll bring it up in a minute so you can see it. But that's my line. Make arrows because remember what this represents? It represents all the solutions to that equation. Every single solution to this equation is on this line. Every single solution for my last equation, 3x minus y equals 9, is on this line. And that's how you graph. So you're doing the same thing except we're getting intercepts. And intercepts are easy to get most of the time. And that takes care of that lesson.